Hi, everybody. Letting everyone in right now.
Hola, ¿cómo te llamas?
Hi, my name's Miss Nano. Learning Spanish.
Sí.
Awesome. That sounds good. All right, y'all. Welcome, welcome. So, we have about 17 of us in. It is Thursday, September 24th. It passed so quickly. Tomorrow's already going to be Friday. Can't wait for that community meeting. Is this the correct? Yeah. Yeah, it's the correct one, right? Didn't I ask this question already, though? Did I? Let's see. Oh, your birthday's Monday. Yes, Ryan, that's awesome. Okay, I probably didn't ask. All right, so into the chat, go ahead and put in what animals, cats, dogs, question mark. It could be anything. There's like little hamsters. There's a turtle. And that way I could go ahead and double check the attendance. Ooh. I remember last year a student brought a snake to class, her pet snake. I petted it. All right, both. Turtles. Turtles are so cute. All right, a lot of dog lovers. Kittens too, not when they grow up though. Yeah, kittens are just so cute. That's why a lot of people adopt kittens, but then they don't like it when they get huge and they like sadly don't want to take care of them. That's why it's good to know. They're only small and cute. Actually, I like big cats too. They're cute. Yeah, kittens are just so adorable. Not grown cats. All right. I mean, I discovered this, I forget what it was called already. I discovered this interesting new animal. I know. Put it on my story. I don't remember anymore. It's gone. Let's see. Oh yeah, Viscacha. I don't know if y'all know what that is. And then I think it's so cute, but lots of people are like, what's wrong with me? This thing. It looks so cute to me. I don't know. A lot of people think I'm crazy though. It looks like a kangaroo mixed with a rabbit or something.
Kangaroo bunny.
It's so adorable. Sorry, but yeah, a lot of people are like, "What is wrong? That is not cute." I'm like, "It does. It's chubby, right?" Okay, sorry. Probably, yeah. Only a few probably think this is cute. Okay, let me move away from that. All right, y'all, welcome. So let me go ahead and announce who I don't have based on the check-in, and yeah, we'll go from there. So I don't have Jalen Baker. Let me know if I missed you there on the chat. Jalen Baker. And if you're friends with Jalen, if you could give him a text to come on in. Next, I don't have Denise. I don't have Carlos. Oh no, yeah. Today's work is due tonight. So don't worry, yeah. Okay. Do I have Sincere here? Sincere. And then also Celia. Right. If y'all can like send them a text to come into class. Otherwise, I'm just gonna go ahead and update the attendance. All right. Welcome, welcome if you just came in. Awesome. Not bad. We just have 4 absences. Yeah, so I'll talk about what's due tonight. The homework was not due before class. Yes, cats and dogs. Awesome. And again, I'm obsessed with that new animal I just discovered, but too bad it can't be a pet. Okay, so let's go over our agenda today. So we just had our attendance and check-in. We're going to be starting off our lesson today with a notice and wonder. Then after that, we're going to take some notes. It's going to be some notes today, so you want to make sure you have your notebook and pencil out. And then we're going to have a checkout question based on, our learning target and what we're supposed to learn. So yeah, asynchronous number 4 is due tonight at midnight. So for this asynchronous, by the way, what you have to do is a Desmos sort followed by some questions on the asynchronous assignment. So you want to make sure you try the Desmos sort. It's a lot. I'll say that. It has a bunch of graphs. So my thing is just attempt it. Don't worry on being correct on the Desmos sort. I mostly want the other information that's in the assignment. So let me just kind of quickly show you rather than me just talking about it like in the air like this. So let me go to my classes. Again, this is due tonight. But the thing is, you're going to get full credit as long as you try. Try your best on it. This is more like information for me. So this is asynchronous number 4 that's due tonight. And if you open it up, it looks like this. Basically, what we're doing is we're trying to apply what we talked about in class the other day about how to match equivalent expressions. There's different ways to do so. There's 2 parts to the assignment. Part 1 is a Desmos sort. You would click here and you have to do the Desmos sort first. And there's a bunch of things to sort, but I do give you tips in the support video on how to do that. I recorded myself giving some tips. Try your best. I put do your best. That's all I'm asking for. It doesn't have to be 100% correct for this one. The part that I do need you to focus on and actually write about is here, part 2, where it says describe what strategies you use to match this card up with what card and what did you do for this card. And these are from the sort itself. So this is where I want you to actually really try to type out your justification. Don't just put, oh, I matched you with blah, and then end it there. Put because. And it's okay if you're not 100% certain, just put maybe you saw similar symbols and we saw similar numbers. What strategy did you use? Or, did you use any of these strategies? Let me go ahead and check out the chat. This hard. I'm trying to tell you. Trying to tell me it's hard? Yeah. Well, let's see. It doesn't make sense to me. Oh, the instructions or like what you're being asked to do. So this one here, for example, you're going to click on here first for the assignment. Okay, everything. Yeah. Some are saying the non-boxable ones were hard. So take a look. It's going to show you this. There's a bunch of cards. I'm going to continue as a student. What you see is this. And it's a bunch of cards that you need to match up. Now, I gave you some tips in that support video on how to do it, but basically you're gonna just try your best to match these up to the best of your ability. Now, this isn't a correct match, I just did that. And again, remember, you can use Desmos. Graph them on Desmos and see if they're a match. And if they're the same graph, when you graph them on Desmos, that means they're the same equation. That means you're gonna combine them like this. And then you're just gonna keep going until you finish combining cards. Like I said, I don't think this matches with that. But that's the main goal for the part 1. And then a question we have in the chat is, how would you graph it? Well, let's take a look. Let's say I have a hunch that these 2 are similar. Right? Let's say I think this matches with this. Let's say I think that's true. Let's go ahead and go to Desmos and check it. That's how I'm going to answer, Rebecca, your question. How would you graph it? So you go to desmos.com, and I demonstrated this the other day, but I'm going to do it again, just if we need it. The extra push, extra support for the homework. So the first card we had was square root of x minus 1 times the square root of x minus 1. So you have to put y equals first, square root x minus 1. And we're going to do it again, square root x minus 1. See how it's graphed there? That's the graph of this. Now I'm going to go ahead and put the other one I thought was the match, which was this one, x times the square root of x minus 1. So you always got to put y equals x minus 1. All right, so there in the chat, y'all, are those the same graphs, yes or no? Can y'all tell me if it's the same graph or not? No. So then, therefore, you're going to make the conclusion that these two are not the same, so I can't combine them. For example, I think I already matched this one up. And how I matched this one up, you could use, the other strategy, like the FOIL method or the box method for multiplying this out. But you can totally see, I believe this is going to give us a correct match. Let's see. So the first part, sorry, was x plus 5 and x minus 1. So I'm going to put y equals like that. And if you zoom out a bit, it kind of looks like it is a parabola, not kind of the parabola. Now the second one that I think matches to is this one. By the way, I made that conclusion according to me, or I justified it because I saw the squared here, and I know if I multiply two binomials, I should get like a squared term. So that's kind of like my justification as to why I thought this matches with this. So I'm gonna go ahead and graph that. So it's x squared minus x plus 5x minus 5. Plus 5x, and the last term was what? Minus 5. There you go. So notice how these two match up because the graphs are right on top of each other. That means they are equivalent. That means I can combine these. So I'm done with this one. Also this one too, feel free to take a picture. These two do match. By the way, a tip on how you would do that, you could use long division if you remember that from last year. You don't have to do it that way though. If you just want to use Desmos to prove that they're equivalent, go ahead and use Desmos. But that's how you would do it, y'all. And that's how you would continue. And like I said, don't worry about being 100% about your matches. I just want to see what you get so far. I hope that's okay. I mean, I hope that's clear, like as far as the Desmos part. So first do this part, try your best, use Desmos or use whatever strategy you'd like to use based on what we talked about here in class. No, so actually we're not gonna go into breakout rooms today. I'm actually pausing to go over the homework that's due tonight because a lot of people requested it. So today we won't be doing breakout rooms. This is actually tonight's homework. So part one, I just went over how to kind of do that. Part two, all you gotta do is just justify. So if you matched up this card to something, why did you do it? How did you do it? Did you use Desmos? What was your strategy? And then here's the last one, describe what you did to match up this card. Again, use because statements, so forth. So that's for tonight's assignment that's due tonight. Any other further questions on about this part before I move us on to today's class? A question, let me just go ahead and answer your question out loud. The question that was asked privately is like, but if we're only using Desmos for homework, how will we justify the answer? That is totally a justification because if you look up here, that's one of the strategies, see? Try graphing them both using Desmos. So that is a strategy. You could go ahead and justify your steps. Like, what did you look for when you matched them up? Maybe both cards have x squared in it, maybe something like that. And that's why you chose to match them up. And then you put them on Desmos and graph them. So Desmos is a justification. You can use that as your justification. All right. Any other questions on this assignment that's due tonight? All right. Great. So that's just going over that because people requested it. Let me go ahead and get out of here. All right, so let's jump back into it. So again, this is our agenda for today. But I did find value in talking about what's due tonight because it's due tonight, and a lot of you had some questions about it. Again, try your best. As long as you try your best and you try your best to write out your justification, you will get full credit on this. I swear, and I promise you. Okay, so we're going to be moving on to a new thing today, something called function composition. You will be needing your notes. And how we're going to start off our notes is with a notice and wonder. And then at the end of class, we're going to have a checkout. So that's our agenda today.
Are we turning the notes?
Are we turning in our notes? Today it's going to be a maybe. So you might have to turn in your notes today. And will I make a YouTube video for this? Yes, I can. So how I've been doing that is as long as you email me or text me on Remind, I will send you the recording. So yes, I could do a YouTube video if you need it. Just remind me though, so I could upload it. It takes like about an hour for this lesson to upload. So just let me know. But I will do one if you need it. All right. Quick thing, our asynchronous assignments again are always due Tuesdays, Thursdays, Sundays at midnight. If you need some more time or anything like that, just text me and remind, and I'm happy to accommodate you to the best that I can. Also, jump into office hours. They're always Monday through Wednesday at 10, right after advisory. If you need any extra support, I'm always going to be there. I'm happy to even like do the assignment together with you as well. All right. All right, let's get ourselves ready for some notes today. We're going to write down our learning target and all of that. All right, let's go ahead and title our notes. You're going to put the date up at the top. It is September 24th. We're going to be talking about something called function composition. So this is a pre-calculus topic. I do not know if you've seen it in Algebra 2. If not, it's okay because this is pre-calculus. Function composition. Our learning target is I can define and evaluate composite functions. You could call it like composite functions. Let me give you all like a few more seconds to get this down. All right, I hope y'all got down the learning target and the title for your notes. Let's move on. So keep this reflection in mind. So at the end, maybe in the last 3 or 2 minutes of class, I'll be asking you this. In your opinion, what's an important step or part when it comes to evaluating a function composition? So that's until the end. Just keep that reflection though in mind as we're learning this new stuff today. You don't have to write that down. Okay. So how we're going to begin our lesson is notice and wonder. So what I have for you here is some examples of function composition. So I'm actually showing you this before I'm showing you how to actually do it. That's because I first want you to take a look at the steps and kind of maybe make some processes and connections in your own mind before I show you how to do it. So what we're going to be doing, so everyone will be participating, is you're going to be putting either a notice or a wonder into the chat about what you're looking at right here. And it could be about anything. All right, let's go ahead and open up notice and wonders. All right, we have some stuff coming up into the chat. Remember, everybody, this is for participation. It's okay if you're taking your time right now thinking about what you notice or wonder. So let's take a look at some of these. I notice the beginning thing has two equations in one. I wonder how that's possible. I know, huh? It looks like two equations in one. How is that possible? How do you go from 3 parentheses x plus 5 plus 2 into 3x plus 15 plus 2? That's a great wonder. Another wonder that I got privately are there are two functions combined. Okay, that's a good wonder. Zion said, I wonder if the replaced x in the blue equation with the 3x plus 2 in the red equation. That's true. So if we go on this side, the replaced x right here with the blue equation, or I think we're talking about this way over here. Okay, yeah, replacing x. I like that word. On the left side, the x and the 5 are both multiplied by 3. I got privately. So they think this right here is like the distributive property. So 3x plus 15. Okay. They got 2 and 1. Yes. Miles said, I wonder what are the different parts of each equation doing? Daniel put, do we write this down? So this right now is a notice and wonder. You do not have to write this part down. Right now we're just jotting down what we're noticing and what we're wondering. All right, next. I notice how they have two equations and combine them. Yes. Another question I got, or another wonder privately, is I wonder how both equations are connected. Yeah, how are they connected? All right, let's keep going yet. If you haven't yet entered in your notice or wonder into the chat, you could do it privately or you could do it publicly. Of course, I prefer publicly so that we can all validate what we're wondering about. And we could also validate validate what questions we have about this, as well as what we're noticing. All right, so those are some good notice and wonderings that we're looking at in the chat. So I'm definitely going to be highlighting words like we're combining functions, we're putting two functions together. Gerardo put in the chat, I wonder if they're connected. Yeah, like are these two functions related in any way? Great. Noticing that they're combining functions. And then some of us are noticing like the processes, like what's being multiplied, what's being added, and so forth. All right, perfect. So let's go ahead and jump into the lesson. So this kind of led us to be more curious now, what is function composition with this notice and wonder activity? So let's go into it. What is function composition? Here we go. Please write this down. So yes, you want to now write this down. Some definitions. So some of you already brought this up when you looked at the notice and wonder, but composing functions means that the output of one function becomes the input of another. So when y'all were saying like, I think you're combining two functions or you're putting two functions together, this is like exactly what you were saying, but this is the more precise way of what was actually happening. The output of one becomes the input of another function. And that's why it looks like two functions are being combined. Please write that down. Now, next bullet. Functions represented as equation can also be composed. And you can think about composing two functions as stacking two function machines. Now, the word function machine, you may have seen it in algebra. People sometimes draw visuals to represent how to evaluate a function. So we're going to take a look at a visual right now, but now with looking at function composition as the visual. Let me go ahead and give you all 30 more seconds on this slide for processing and also to write this down. And or any questions as well. All right, let's go ahead and shift into an example. So please go ahead and copy down this visual. So this right here is a visual representation of what's actually happening when we're doing function composition. And when they talked about function machines, so right now you should be drawing this down, by the way, while I'm talking, please draw this down. Of course, you don't have to draw an actual machine. You could just draw little boxes and arrows. But if you think of it, this is like one machine, and then this is your second machine. So they're like two machines happening here. Go ahead and just take a look, draw the visual. We're gonna go ahead and talk about it. All right, I'm hoping you got a little good sketch of this down. Now let me go off to the side here on the left-hand side to just describe what's happening. And let me see the chat. There is a no. That's okay, don't worry. I'm not moving on from the slide. I'm just gonna be on the left-hand side right here. Go ahead and take your time if you're still drawing boxes there. Let me go to the left-hand side. So to just describe what's happening. By the way, y'all, when you're taking your notes, you don't need to write word for word. Just write the general gist of what's being said. So the visual right here shows two functions. One of them I'm gonna color code in red is f of x. And the first function is 4x plus 7. The other one is g of x, and I color coded that in purple. It's x squared minus 3. And they're being composed here. That's what this function machine is showing. And what you're ultimately getting at the end of the function machine is something called g of f of x. That's how you read it. Whenever you see a parentheses after it, you say of. So g of f of x. And then you don't say of when the parentheses is at the end of it, of course. So again, if you take a look at your function machine right here at the bottom, this is what you get as your outcome. You should be getting this function composition. Again, notice how that's taking a function and you're plugging it into another function. In this scenario, f of x is getting plugged into g. You could also notice that happening in the function machine because f of x comes first. So you drop x in here, and then f of x goes into g of x. And your outcome is what we want, which is the function composition, g of f of x. Let me just pause here for any questions, and then we'll have another bullet. All right, let's go on to the next piece of fact. So notice that at the top of the function machine, right at the very top, notice that x is getting dropped down first. So x goes first, and it first gets plugged into the f function. And then whatever the output is gets plugged into g of x. So first notice that, right? X gets dropped down, goes into f. The outcome is f of x, and that outcome gets plugged into g of x to give you the ultimate final answer. So that's just something to notice there. And why I'm pointing that out is because when you're looking at this function composition, the function you do first is the innermost function. That's the one that's right there in the innermost parentheses. That's what we mean by the innermost function. So we're going to start with f. Let's do an example, everybody. Let's do an actual example of this. Let me clear my annotations. All right, example 1. Let's try to evaluate g of f of 1. Step 1. If you have any colors or markers by you, I would recommend this, especially if you're trying to learn like how to do this. I like to color code my stuff. So I color coded it. I made F be the red function and G be the purple function, just so I could keep track of what's happening. So first things first, so with function compositions, as you could see in the machine, you have to do the innermost function first. So we got to first evaluate what is f of 1. That goes first, because if you notice, 1 gets dropped in. That's your input. 1 goes here. So I need to figure out what is f of 1. There's something in the chat. Oh, okay. Perfect, perfect. All right. So when 1 gets plugged into f of x, sorry, can someone in the chat tell me what do I get? So if I plug in 1 into my first function right here, what do I get? Oops. So I want to figure out what is f of 1. What do I get when I plug that in? Let's see our chat. All right, so Danny put we get 11. Let's go ahead and verify that. Let's see if anyone else got that, and if you didn't, or if you have any questions, I'm gonna go ahead and show you. So let's see. So, oh, let's see the chat. All right, someone else got 11. They private messaged me. All right, let's go ahead and check then. Do we actually get 11? A lot of us are saying yes, we get 11. All right, so if I plug in 1 in for f, it looks like this. F of 1 equals, so that means it's going to be 4 times 1 plus 7. All right, 4 times 1 is 4. 4 plus 7 does indeed get me 11. Yes, our answer is 11. Oh, it already showed here. So yeah, we get 11. So then my next step is, instead of writing f of 1 right here, we're going to rewrite it as the output that we got. So when I plugged in 1 into f, I got 11. So now I rewrote my second step as g of 11. Let me check out the chat. Great, so a lot of us got 11, great. So again, step 1, plug into the first inner function. Once you get that output of 11, then our next step, if you look to the left here under example 1, you're gonna rewrite your function. So it's gonna be g of 11 now. Now, in the chat, once we get an output of 11, 11 is gonna get dropped down into the g function now. What do I get when I plug in 11 into g? Oh, okay, so there's a question before I ask that other one. How come it's g of 11 rather than f of 11? A great question. So because what we did is, right now we evaluated f of 1 right here, right? When we evaluated f of 1, we got 11. That means f disappeared because we evaluated it. We still did not take care of g, so we need to keep the g on the outside still, like this. I hope that makes sense. Let me know if that makes sense, Cyan, but okay, kind of. Yeah, so once we evaluated with f, the f should go away once you get that output. That's why the inner part became 11, and now you're gonna take 11 and you're gonna plug it into the g function, because we didn't use g, so we still need to keep g on the outside. Yeah, and then Sam right there in the chat kind of put his own version of describing what just happened as well. Awesome, awesome, thank you all. Okay, so now the next part is, so we're only halfway done with this, right? We have g of 11. We still need to evaluate what is g of 11. So if you look here in the function machine, 11 needs to get dropped down and plugged into g. Now I believe somebody already answered it in the chat. They got 118. Let us know if anyone else gets that. Well, it was Danny put 118. We could go ahead and verify if 118 is correct. Let's see. Let's do some of the work here. So that means I got to figure out what g of 11 is. So g, wow, of 11 equals, that means right here I got to plug in 11. So it's going to be 11 squared minus 3. 11 squared is 121. I see some stuff in the chat. And we get minus 3. So yeah, I think 121 minus 3 is indeed 118. Yes. That means at the end of all of this, g of 11 is 118. Great. And then everyone else there in the chat seems to agree. Yep, Miles and everyone. Yes. Oh yeah, the exclamation point. I know, it's like I'm yelling. Awesome. So yeah, so then we're done because we have no more functions left over. There was just 2 functions that we had to plug into. So our answer is 118. We have successfully evaluated g of f of 1 in this case. That was the problem. G of f of 1. All right, let me just leave this 15 more seconds in case you need some time to get last bits down. And then we're gonna do some more examples. So this is the more like spelled out example. We're gonna get into some pre-calc examples. But you know, bear with me, ask your questions. It's okay to take our time learning this, of course. All right, let me clear my drawings, everybody. Oh no, someone said something in the chat. Awesome. Yay. We're understanding some of this. It's great. Let's see what the next one's about. All right, this one might involve your concentration. So now let's write down example 2. So example 2 says evaluate g of f of x. Notice how there's no numbers in for x. We're actually gonna plug in a function into g, if that makes sense, without even a 1 in there. So step 1. Step 1 is color code always. For me, if you don't have color coding, that's fine. But for me, it just helps me see what's happening. Okay, so one thing to notice is we don't have a number for x, right? There's nothing to plug into f. So what we're going to be doing instead is, instead of just plugging in a number here, what we're going to do is, okay, if I plug in x into here, all I get is f of x. So that means I'm going to be plugging in the whole function f of x into g of x. So for this one, I'm not going to get a number as an answer. I'm going to get another function. So that one's going to be interesting, this example here. Yeah, so this is going to be interesting, but don't worry, we'll get some practice on this. Okay, step 1. Even though this looks slightly different from the last example, you still are going to start with the innermost function. The innermost function is f. That's the one with the innermost parentheses. So if you look over here to your graph, or I'm sorry, your function machine, your f of x is 4x plus 7. So what I'm going to do in my next step is I'm going to replace f of x with what it is, 4x plus 7. Y'all see that first step I did there. F of x became 4x plus 7 because, according to the drawing, that is what f of x is.
So basically, you just solve f with the equation instead of plugging it in?
That's correct. Yes. And Danny put, wait, so we're using the same /last equation? Yes, that's correct. We're using the same function machine that we did for the last one, but this time we don't have a 1, right? We're now doing a general function. And I'll pause there. So basically now the question is, how in the world do I plug in this whole function into g? Because that's what it's telling me to do right here. This is saying 4x plus 7 has to get plugged into my g function. This whole function has to get plugged into g. So basically this is how we have to think about it. So this is my g function down here. It's x squared minus 3. Instead of x, So let me circle where x is. Instead of x, we need to substitute what f is. F is 4x plus 7. Let me show you how that substitution looks like. Oh. So notice how instead of x, I plugged in the whole function f of x, which was 4x plus 7. Let me just pause here to see if anyone has questions on this step.
How did you plug in f of x if you solved for it already? Wouldn't you be plugging in g for x or?
So if I solved for it already, so for example, you know in the first one where I plugged in 1 and then I got an output of 11, right, for f? But this one, we have no number that we're plugging into. So we have to actually plug in the whole function f of x into g. So this whole thing. So this whole thing, and I'm circling it over here, has to get plugged into x right here.
Okay, I got it.
Yes, and keep the questions coming because this is, you know, it trips up a lot of us. All right, any other questions? I'll pause here, either in the chat or you can unmute. And the slides are going to be on Google Classroom. Yeah, they're already there actually, yes. I moved them to the top, but they're there. It also has all your future lessons on there. And I also have, you know, I could give this as a recording as well. All right, everybody. So now, after we've reached the third step right here, right? Yeah, and a video would be great, yes. Let me go ahead and I'll make sure that I send the video. I could also send it on Remind as well for this class. Once it's uploaded, again, it's gonna take like an hour for it to upload. And by the way, we're gonna do more examples. I'm hoping more examples we do, the more it clicks. Okay, but now that we're here, I mean, here you're technically right, but the answer is not fully simplified. So we just need to work on simplifying this and then we'll be done. Because we already have g of f of x, it's this, but we wanna simplify our answer. So how we simplify our answer is, notice there's a square here. Oh, okay, so Danny in the chat put box method, so box method. Yeah, because notice there's a square there. That means you're gonna rewrite that as this, right? Because squared means multiply by itself twice. So if you use box method for this, right? What you'd get is this. Let me underline that part. So right here, we use box method and we get this when you use box method. Let me also type that out right here. Box method. And then I'm going to show you how I did the box method in a second. After you have this simplified to this, all you got to do is combine like terms. The only like terms in this equation are the 49 and the minus 3. So 49 minus 3 is going to give us 46. Yes, yes. And I think that's as far as we can go. I think that's our answer. And there's my box method, everybody. I included this on here just so you could see where I got that part that I just underlined. So there's my box method. Oops. Now let me just pause here for questions. This is our answer. It's finally simplified form right there. And we're gonna be doing more examples. But I'm just pausing here.
Wait, hold up. So if you had a number to replace the x,
Mm-hmm.
will we instead use that number?
Yeah, so if you had a number to go in for x, like we did for example 1, then it would be more straightforward. You would plug into the first function and then you take the output, plug it into the second. Yeah.
Okay, but if we don't have a number, then we'll use the equation in the first box and plug that in for the second box.
That is correct. Yeah, perfect. I like how you phrased it. Awesome. Great questions and great like rephrasing of what just happened here. And again, we're going to do another example, but definitely keep the questions coming. All right, I'm going to go ahead and clear all my drawings and get ready for the next example. All right, I hope we're ready. Oh, there's something in the chat. Awesome, awesome. We're getting some people saying they're getting it. Okay, awesome. All right. Okay, so now we're gonna try to do examples, but without that function machine drawing, right? We're gonna do it like this. Let's go ahead and copy down example 3. So this is without the visual, is what I mean. All you have is your functions are given to you and you're asked a question. Let's copy this down. And for this problem, we want to figure out what is g of f of x. So again, this is going to be without the visual, without the function machine picture to help us out, but I'm going to walk you through the process. And again, it's very similar to how I think it was Zion that worded it right now about, so that means we're just going to plug in a function into another. That's exactly what we're going to be doing. All right. I hope you all got this example written down. Now then, step 1 is I like to color code. So again, I made my function f as red, my function g as purple. Now this is saying that I need to take f of x and plug it into my g function. So I'm taking f and I'm plugging it into g. So basically what you're gonna have is this whole thing is gonna get plugged in right here for x. Let me circle that, like this. But let me go ahead and walk you through the steps. So usually how I do the next step right here is I ask myself, okay, what is f of x? F of x, according to what was given to me, is 2x plus 5. So I'm going to rewrite this as g of 2x plus 5, because that's what f of x is. So that's the second step. Once we hit this second step, this is telling us that I need to plug in this whole function into g. So I got to plug in 2x plus 5 into g. What that means is that x is going to be replaced with 2x plus 5. Oops. There we go. Too much circling. All right, let me show you what that looks like. Notice how the f just got substituted into g. So 2x plus 5 replaced the x in the g function. And it's in red right there, what got replaced. Now in the chat, basically like this is my function composition, but now I gotta simplify again. So in the chat, what should I do to simplify this answer that I have so far? What can I do? All right, we got an answer there, FOIL. And then we got, someone said the answer would be 4x squared plus 26. Let's go ahead and check out what the answer will be, everybody. Let's see. So yeah, I agree. We gotta take care of the fact that there's that squared term right there, right? Whenever you see this, you see a binomial that's being squared like this, you either could use FOIL or you could use box method. I think I did box method just because I know a lot of us are comfortable with box method. So again, the squared means you multiply these 2 times. When you use box method and multiply these 2, you should get this. So this part becomes this part. And then the like terms you add is 25 plus 1. That's 26. And let me show you my work for my box right here. It's in the bottom. Hope you all can see that. And I see some stuff in the chat. Let me go ahead and pause. Here's an arrow. So let's see. Great, great. So I got that private chat. Good. We wrote that correctly. What's FOIL? So FOIL is like another way to do the box method. You don't have to do FOIL if you like the box method. Oh, okay, okay. So yeah, so it becomes 20x because you've got to remember that when you do that box method, that you add the diagonals. So 10x plus 10x is 20x. So that's how I got that answer right here. So check out the box method right here. So check out how I got, you know, this multiplication in. And then basically, that's okay. I mean, it's been a while since we've done, you know, a lot of math, so it makes sense. But basically, once you're done simplifying, you added all your like terms, that's it. This is our answer, everybody. Cool, let me just pause here for any other questions. Questions, clarifications, anything like that, I'm happy to go over. Did it? I feel like I was talking a lot. I really like it when everybody's in groups and engages instead, but yeah, it did go quick. All right, everyone. So I did have another example, but we can hold off for that because I do want to get into our checkout question. The next example, if you're curious, for future class looks like this. So basically in this example, oh, it's going to be very similar actually. So we'll hold off this example until Monday, but feel free to like check it out and try it out on your own. Let me go ahead and jump us into the checkout question. So again, let's remember our learning target. Our learning target is I can compose and evaluate function compositions. Right now, what we're doing was function compositions. And this is what I'd like you to put into the chat right here. Okay, so in your opinion, so right now everyone should have maybe a different opinion on this. So what is an important step or part when it comes to evaluating a function composition? So in the chat, go ahead and put what do you think was an important part or step? Okay, so I got one, a private one said solving for F. Solving for F was an important step. Awesome, awesome. I got another one privately, plugging in the number. Okay, so that's an important step, like knowing what number is getting plugged in. Simplifying the F input, plugging in your values correctly. Awesome. Plugging in the first value. When plugging in the F and the X, okay, awesome. Knowing if X is a number for the first step, yes, that's a big important, yeah, because if X is a number, you're gonna have a different process, right? That's a good one. Yes, plugging in the function correctly, that's a huge big step. Plugging in the values, finding out what is X, knowing what numbers to plug in, finding X, plugging in your values correctly, and knowing that X is the number. Awesome. Ooh. I like that second, that one there. An important step is making sure to plug in the second function correctly. Yes. Yeah, like the order does matter for this. So that's true, and plugging it in correctly. Awesome, y'all. Thank you so much for your reflections. Do make sure that you put in your reflection if you haven't yet. Yes, plugging in the function. Great. So again, we're going to come back to function compositions and continue this learning target for Monday. But yeah, keep your reflections in your mind. Until then, y'all have a great day. Tomorrow's Friday. Make sure you get to relax. And don't forget about your asynchronous, though. Make sure you get that in tonight. Bye, everybody. Bye.
All right, then. See you later.
Yeah. Bye.
Bye.
Bye. Peace, everyone. Peace. Let me go ahead and upload this video.